Thanks a lot. Yeah, it's great to be here. I hope everybody's good. Everybody's good after lunch? Cool, okay. So I'm very happy because Kehelia he introduced all the concepts, and Felipe and the guys, so we have the concepts nailed. So now I can focus on more of a practical perspective. So yeah, so this talk is going to be a little bit different than the other ones we had before. Let me just get back. It's going to be a little bit different. It's going to be more code focused, okay? So it's going to be more practical, and I think it's going to give it a nice bootcamp vibe. And yeah, so I'm going to be talking about Agentic software and development platforms for this type of software, right? Okay, just give me a sec. Okay. Right, okay. So this is the overview of the session, okay? So I'm gonna give it an introduction. Then there's gonna be a deep dive into Microsoft Autogen with examples. So this is what I'm gonna be focusing on. Then I'm gonna, say a few things about how you can have a nice playground for experimentation using Autogen. I'll briefly mention other agentic development platforms and frameworks, and then standardization efforts for FM-powered agents, and what's next, right? Okay, so introduction. So this idea of multi-agent systems have been around for a while, as Kehelia pointed out. And here I'm gonna be a bit, it's just a shorter view, right? He presented different concepts and stuff, but here's more of a pragmatic view, perhaps. So the idea is basically you have these multi-agent systems, and they're designed around these autonomous agents, right? That interact with each other to achieve some broader goal, right? So that's the definition that I'll be sort of sticking to. Suitable architecture. Usually we use this type of architecture when we have complex problems that we're trying to solve, right? That require decomposition. And with the advent of foundation models, the community quickly realized the potential of FM-powered agents and FM-powered multi-agent systems, right? And shortly after, people were like, yeah, I guess we need a framework to work with, right? To be able to develop these agents, right? And that's sort of when Autogen came out. So it became really popular late last year. And Kehelia talked about Baby AGI and some other applications, but I think a lot of these applications, they actually showed or gave inspiration, right, to Autogen and how it should be designed and what problems it should try to fix, basically, right? So the key point of Autogen is it's this reusable framework, and what they want to have is this basically support these conversation patterns, right? So Autogen is all about agents and conversations and conversation patterns, right? And we also want to have code execution capability and human in the loop to steer these agents in the right directions, right? And here I want to have this disclaimer, right? So the cognitive architecture is really the key value of these agentic systems, right? So it's not really about the models because, of course there's cost to use these models, but they are basically available for everybody, right? Everybody can use GPT-4o or Claude Sonnet or whatever next model we have. So the key value, the IP of your agentic system is really on this cognitive architecture, is in the answer to these questions, right? So how many agents should I have? What roles should they play? What models should they use, because different agents can use different models, and how should they communicate with each other, and how much human intervention. So these are hard questions to answer, right? And this is fundamentally a software engineering problem. So I think this is the perfect intersection of AI and SC, right? Okay, so let me now talk more about Autogen, okay? So I'm gonna be showing a lot of code, and the idea here is to help you get started, right? Because you heard so many concepts, there were so many presentations, right? So I just wanted to show something practical. So this is almost like an opinionated view on all the concepts that have been shown and how Microsoft has implemented them, basically, right? And this is, again, I have an hour and a half, whatever, so I cannot cover everything. This is just to get you started and give you pointers, right? And then you hopefully can go from there. Cool. So Autogen, how do you install it? This is pip install, right? So it's just a Python package. Okay, so key concepts, how does it work, right? So, okay, agents. So agents, they can send and receive messages from other agents in a given environment. And you have this main class, conversable agent. And it has these components, these 4 things, basically. So it can have one or more LLMs that it's going to be interacting with. Use it as the backend, basically. Can be a foundation model. I'm calling it LLMs, but just any foundation model, right? Or it doesn't need to have one FM, but it could have one or more. It can execute code. It could have the ability to call functions and tools, and also this idea of having the human in the loop, right? So yeah, so this is the archetypal conversational agent that Kahalia was talking about, right? So how do we play with these guys, right? So there's this generate reply method that takes a question and generates a reply. Okay, so how does that work? Conversable agent, okay. This is the key API, you give it a name. This is the configuration for the model that you're using. So basically this is your open API key or whatever, right? And for now, this is a very basic agent, so we're not going to bother now with code execution and functions, and we're not going to have any human input for now, no human intervention. So this is like probably the most basic agent you can have in Autogen. And then how do you generate a reply? Okay, so you do agent.generate reply, tell me a joke, I am the user. So then you get something like this. Sure, here's a lighthearted joke for you. Why don't scientists trust atoms? Because they make up everything, right? So that's a joke, okay. Not the best joke, but it's kind of funny, right? Okay. What else? Okay, so personas, right? Felipe talked about it. I think Kahalia touched on it as well. So personas and conversations, right? So typically in these multi-agent systems, agents will embody a persona. A persona is typically assigned using a system prompt, and in the world of Autogen, it's called system message, right? Agents participate in conversations. A conversation is just a sequence of messages, and they are employed to make progress on a task. Again, agents are just these many things that are interacting with each other, communicating with each other to achieve a certain goal, right? So a conversation is started with initiate chat, right? So you have a recipient, you have message and max turns. There are other parameters too, but recipient is going to be the agent receiving the message. Then you have the message and the max number of turns you want to have in this conversation, right? So now it's a slightly more interesting example where you now have 2 agents, right? They have been defined very similarly. So notice here that for the model, you can even specify parameters like temperature and whatever. So your name is Kathy, and you're a part of a duo of comedians. Your name is Joe, and you're part of a duo of comedians as well. Now, if you then start this chat with Kathy, tell me a joke, then they'll start talking with each other, right? Which is kind of cool. And 2 turns, right? I established this parameter for the chat. So basically, there's going to be a first turn and a second turn, and that's it, right? So Kathy, tell me a joke. Sure, here's one for you, blah, blah, blah. So they start talking, right? So hopefully you can see now how it's starting to become like an agentic thing where agents are bouncing off each other and stuff. You had a question?
Yeah, sorry, where did you define
the names? Sure, so it's right here. Yeah, it's the first parameter, yeah. Cool. So the other important thing when it comes to agents is you want to make sure that this conversation ends, right? Because if it doesn't end, then things can go wrong. You can pay a lot of money and so on, right? So it's important to know how to stop conversations, right? Okay. And how do you do it? So first, let's think of it like without human in the loop, okay? So yeah, it's for any complex conversation you want to know how to stop. So basically you have 2 options, right? So one is max turns, as we saw. So I say 2 turns and that's it. You guys are going to talk to each other twice and that's it. That's a parameter of the conversation, but you can also have parameters for the agents themselves. So you can have max consecutive auto reply. So it's going to reply a given number of times to the same sender. Or you could establish a termination message. So basically, the idea is the agent receives a message, and then you can define this function. So basically, typical things are like if my message is only terminate, then I terminate, or my message contains the word terminate, then it, or it could be anything, right? You just want to, basically, you just define a function to determine how the conversation is going to stop. Now, there are a few things, right? Like with, if you go to Microsoft Autogen documentation, some things are a bit tricky to figure out. So one of these things is if you don't say anything, if you just put none there for is termination message, actually what's going to happen is the agent will stop responding if it receives a message that has only terminate. So this is the default mechanism, basically. So agents in Autogen, if you don't do anything, they will only stop talking if they get a terminate message, okay? Cool. So here is the same kind of dialogue, right? But we're using max consecutive auto reply, and this is just one for Joe. So you can see how Joe only answers Kathy once, and then it stops there, right? We can use termination messages, as I was saying. So you literally define the function here. So it's just a lambda working on message. So basically, yeah, you're gonna see if there's a goodbye, and you're doing like a lowercase first. So yeah. So Kathy, tell me a joke, and then say the words goodbye. So then she's told a joke, said goodbye, and that's it. Then it ends, right? Because it has a goodbye there, and we have lowercase, so it ends. Cool. Just another example, right? There's this guess the number game, right? So this is a slightly more sophisticated prompt, but this is just to show again the two agents talking to each other. But the key idea is one agent has this number in his mind, right? And the other agent kind of has to guess if this number, right? So the number is 53. This is the termination message here. So yeah, so it says, I have a number between 1 and 100, guess it. And it says, oh, is it 50? So it's kind of doing binary search, so it's smart, right? And it says, oh, too low, is it 75, too high? And eventually it gets to the 53, right? So again, I'm just trying to show practical examples of how these agents would be kind of talking to each other, right? Cool. Human in the loop, so how does this work? A lot of times you want to have more control, right? Sometimes you don't want to just leave the agents doing their stuff. You want to perhaps intercept a message, or you want to stop a conversation or something like that, right? Many applications actually require human feedback, right? And there are, in Autogen, there are these different input modes. So maybe let me talk a little bit about this first. So this is the mental model, the domain model of a conversable agent. So you have messages coming in, and they have what they call this human in the loop component. So basically, depending on how you specify it, you can intercept the message, and then the human can choose to do nothing, to reply to the message, instead of bypassing the agent itself. So you take control and you answer it. Or you can terminate the conversation. And again, Autogen has these weird things in terms of terminology. So they use auto reply, but this literally means let the agent reply to the message. So auto reply is like agent reply, right? So what can you do? So never, so you can say never. So human input is never requested. So this is like fully autonomous agents, right? Always, then this parameter is ignored, and then the human is always prompted to either do nothing, reply, or just terminate the conversation. And terminate, human input is only requested when that termination condition is met. So the conversation ends, and then the human is brought into the loop. Okay. So here again, we're going to play a little bit with this. So let's say human input mode is always, right? So same thing, conversable agent name. Note that this is sort of, again, being like a human proxy, so I don't define an LLM for it, right? And the human input mode is always, so always ask for human input. And start a chat with the agent, try to guess the number again. This is the same agent that we defined before, and the message is 10. So here, human input is prompt. The human is prompted every time, right? So the agent says 10, and then it goes too low, 79 too high, 76 too high, right? So it's just the human being there talking to an agent, basically, right? Human input, so for terminate, again, the human input is requested when the termination condition is triggered. Human can, if the human chooses to reply, then that counter is reset, the max consecutive reply. Human can choose to skip, and then the agent will reply. Basically, if the human does nothing, the agent replies, and the human again can choose to terminate the conversation, right? So you can define, again, this conversible agent. They're trying to guess the number again. And yeah, so here we define the number, where's that? Blah, 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 blah. Human input system, blah, blah, blah. Yeah, max consecutive auto reply. So this agent is replying once, right? So again, is it 50 too low? So that's the first answer. And then is it 75? So because the parameter is just one, now the human enters because it reaches a termination condition, right? And same thing, you let the agent answer once, but then it's the human that's answering. So this is just to show, again, you can, basically the human can answer everything. He can step out, he can be there kind of working together with the agent. So there are all these different mechanisms, right? Okay, so the other important thing is code execution, right? So in Autogen, there are different ways to do it. So a code executor is a component that takes an input message containing code blocks. It performs the code execution and outputs messages with the results, right? So there are two different types of code executors. You have command line executors and Jupyter kernel. So command line runs on a shell, and each code block is executed in a new process. So imagine you have like a certain message, right, that maybe was generated by an LLM, and maybe you have different code blocks. So what it's going to do in terms of execution, each code block is going to run on a different shell session. It's stateless. And yeah, and then, but you can also have a Jupyter kernel, right? And you can run this either locally or on a Docker container, which is pretty cool. So yeah, so for local setup, just a disclaimer, right? So when you're talking about code execution, these LLMs could literally just write rm minus rf and destroy everything, right? So if you're working on a local setup, meaning things are happening on your own operating system, be careful. If it's a virtual machine, then you're good, probably, right? But just be careful if you don't use Docker, right? Because who knows what these agents could be producing in terms of code, right? But the way it works, basically, again, is this code execution, right? So you get some message that has code blocks in it. Then this agent is going to figure out what the code blocks are for you, which is good. Felipe even had a paper where it's usually hard when you're working with LLMs to decide on the output format. Maybe you say, give me JSON, and they say, here is the JSON, and then they put the JSON. But sometimes you just want the JSON, right? You don't want any other message. Sometimes it's in a code block. Sometimes, so parsing this is tricky, right? So I'm glad that actually Autogen sort of takes care of this by itself, which is kind of cool. So basically, it's going to identify the code blocks. It's going to put them in a file on your local operating system and execute it. It's going to take the output from the console and put it back here, and that's the output, right? Now, if it's on a Docker environment, then this file is created inside a Docker container, executed inside the container, so much safer, right? This is probably what you should do for the most part, but here, just to make things simpler, I'll just talk about the local setup, okay? So how do you do it? So yeah, so conversible agent again. So now we're introducing this other parameter, the code execution configuration that has an executor. And this is the executor on top. So yeah, so basically this is the local command line again. So not a Docker, local, and it's command line, not Jupyter. You can specify a timeout because computations could take long, whatever. And temporary directory in this case for these files to be created and stuff. And basically, that's just it, right? So you can create a message. Here, I'm just creating a message with a code block. So the code block is below Python, blah, blah, blah. This is the end of the message. So if you send this message with code block to the code executor agent, it's going to do all of that, and in this case, it's going to produce a scatter plot and an image, right? So this is just to say, basically, if you have a message that has code blocks in it, you can get your agents to literally execute it, right? And then now you have code execution, which is pretty powerful. Because we don't want necessarily to use LLMs for everything, right? I think that's a key concept in the software engineering 3.0 vision, right? You're going to have LLMs generating stuff. You're still going to be using your legacy or traditional software engineering as well, and your tools and all of that, right? So yeah, so this is again with local setup. A slightly more interesting example. So instead of having like a predefined message with the code blocks, so here we have two agents, like a code writer and the executor. So the code writer sends messages with code blocks to the executor, it executes and sends it back, right? So same setup here on top for the executor. You define the executor here, the agent here, and then you pass the executor to this guy here. And this is a code writer agent, right? So that produces code. So there's this system prompt here, but basically it's just saying that it's, you know, a helpful AI assistant that can generate code, right? So yeah, so you define it with an LLM. Nothing fancy going on here. And now we're using the code executor to initiate the chat. This is not the typical scenario. You would probably have another agent do it and not the executor itself. But just to get things started, right? So the executor agent says, let's initiate a chat. So it's sending a message to the writer, write Python code to calculate Fibonacci, the 14th Fibonacci number, whatever, right? So then, yeah, so the executor asks the code writer, hey, give me this Python code. It uses LLM and generates this thing. So then it goes to the executor agent that outputs 233, and then the writer then talks about the result, right? So you can have, again, you can have agents talking to each other and running code, right? That's basically where I am at right now. Now, a tricky question maybe here. So is this conversation over? So is it going to end here? So if you go back to how we define the agents, right, you see again that we didn't specify basically anything in terms of how this thing should end, right? We didn't put max turns or like the termination message that we saw before, so there's nothing here. So is this gonna end? So the answer is actually no, right? So even though it says terminate here, remember that if you don't do anything, it only stops working when it gets a message that only has terminate. So the real execution really is more like this. So it goes, there's like another cycle where it just answers terminate and then it finally terminates, right? So this is just to show these little things that if you're not careful, you might be wondering like, why is this not ever ending, right? And this is again because we didn't specify any termination criteria here. So ideally you should define something like, oh, if your message has terminate or whatever, right? Depends on how your system prompt is written. Okay, and this is just to show quickly how you would do it with Docker. So it's reasonably simple. So you have an image, you have a timeout, you have where the thing is going to be mounted, and that's it. And then you just pass the executor again, right? So it's you just basically need a Python. You just need a Docker image, really. That's the key point. Okay, we're making progress. Okay, tool use. So what are tools in the universe of Autogen? So tools are predefined functions that agents can use to search the web, perform calculations, whatever. Tools, they give you this more control, give you higher control over what the agents can do, because again, LLMs are cool, but we don't necessarily want to do everything using LLMs, right? Maybe if you have a very good traditional software engineer, like a traditional tool, you just call it and get the job done, right? So how do we create tools? Tools in Autogen are Python functions. Now, this doesn't mean that your tool needs to be implemented in Python. It just means like Python is your gateway, right? It could call a web service, it could invoke something else, it could invoke a shell script. It's just, it could be anything really, right? But your gateway is basically the Python functions. And then the cool thing is you if you ensure that you use type hints when defining these functions, then you basically don't need to do anything else, like magic happens, right? And I'm going to talk about it. So the way it works in Autogen is you have to have two agents, really. So one is you're going to register the tool signature through this register for LLM. So again, Kehelia talked about a little bit about this, but the key idea here is you define the function and then you register it. So then the agent becomes aware that it has that function or that tool to be used, right? And it's going to use LLMs to decide if it should call that tool that it has in it for its disposal, right? There is one agent that is going to be reasoning about whether it should call a certain tool and figure out what the parameters and everything should be. But the execution itself is done by another agent, right? So just to show kind of how this would work with a very simple example, okay? So let's start with the calculator. I know it's boring, but it's a function that calculates stuff, right? So here you use type hints, right? So you say A is an integer, this is an operator, annotated, blah, 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 and then your return type. So, you can even use Pydantic for this if you want to have more control over the schema. But basically, once you define this function, you're sort of good to go, right? So we have the conversible agent here. You are a helpful AI assistant. You can help with simple calculations, return terminate when the task is done. Here we have this user proxy agent. Again, that basically checks if the message is not done. So basically, if the message has terminated, then it's going to terminate. So then here is where we actually register the tools, right? So for the assistant agent, which is this guy, we're saying, hey, you can use the calculator, okay? Like since it does calculations, here's a calculator for you, okay? And then the user, here again, I'm using the user proxy, but you could have defined just another agent for this. But because this is always going to start, this guy is also going to start the conversation, so that's why it's user proxy. Sort of doing two roles here, but anyways. So this is the guy, the agent that will actually execute the function, okay? So after you do it, you can see that if you go to the assistant and do .llm config tools, you can see how it, like Autogen sort of magically defined this schema, right? That is compliant with the OpenAI way of defining the schemas for tools, which is kind of cool. Okay, and how does it go? So user proxy, initiate chat. What is this crazy equation? Well, not crazy, right? That's this calculation here. So the user asks the assistant, like, what is this, right? And then here's the magic happening, right? So this assistant, powered by the Autogen frameworks, because it knows it has a calculator, it kind of figures out, okay, I can use the calculator. So it suggests a tool call to the calculator. These are the parameters. And then it gets some numbers, right? But then because this is sort of like a little equation, so you have to do many operations, right? So so here, again, you see the call, and here's the execution, and then it runs for a few times until you get the final result, right? Again, this is just a calculator, but it could be as complex as you want, right? This is just the mechanism, basically. Okay, now this is perhaps the most interesting part, where you have the conversation patterns. And again, I'll go back to Kehelia, right? Like Kehelia showed like a gazillion different ways of doing conversations, and Autogen has its interpretation of what conversations are and what types of conversation patterns it offers, right? So overview, so basically there are these 4 types available out of the box in Autogen, right? So you can do the 2-agent chat, which is what we've been doing, basically just agent to agent, agent with humans. You can have sequential chat, which is, I think Kehelia called multi-step, if I'm not mistaken, chat. So it's a sequence of chats between 2 agents chained together by a carryover mechanism, which brings the summary of the previous chats to the context of the next one. So it's like a little sequence of chats, as we'll see that. Then we have group chats, and this is kind of cool. Basically, you use this when you have more than 2 agents, right? So maybe you want to go fancy, or you have a very complex problem that you have to decompose and have many agents work together to solve it. So this is probably one of the things you could potentially use, or you would use. So yeah, this is basically a single chat involving more than 2 agents. Now, there are several different strategies to define the next speaker. Could be round robin. We're going to go through this, but basically it could be round robin, random, manual. So the human says what the next agent should be, or you could the most interesting perhaps case is when you just let the LLM decide who should talk next. Okay. Selection of the next speaker can also be defined by some function that you have. So maybe you want to specify an algorithm to pick the people to talk. And you can also constrain. So we're going to check this out. We can constrain which agents can talk and cannot talk, and we'll see that. And then we can have also nested chat. So maybe you have two agents talking to each other, and then maybe you have a group chat, but you want this whole thing to be accessible as a sub workflow, right? You just want to have one message in and some result come out. So then you also have this idea of nested chat. So it's basically like a sub workflow. So you just send one message, a lot of stuff happens in there sort of transparently, and then you get your result back, okay? Two agents. So this is what we saw before, just perhaps the final version of it. So you have one message coming. Now I'm introducing this summary method, right? So basically the message comes in, the agents talk to each other, and then it offers this summarizer component. So this is very valuable because tokens, they cost money, right? And maybe you don't want to save the entire conversation to know exactly what happened. So it's very typical that in the end, you would have some sort of summarization thing going on. And in this case, Autogen, for instance, has reflection with LLM. So basically, it takes all the messages that were exchanged here, and then it summarizes this conversation. This is, I think, the default prompt that it uses, but it can be customized, right? So not only agents can talk to each other, but maybe they talk a lot. They're working on some solution back and forth. But in the end, you want to have some summary of what happened, right? Because you don't want to maybe store everything, or you just want to, for observability purposes, it might be good to have just a little summary of what happened, right? So then you use this summarizer. Okay, so how does this work? As we saw before, the only new thing here is this summary method. I'm not even showing the messages in this case, but it's like a student that is willing to learn and a math teacher. And they're going to be talking in two turns, so 2 rounds of conversation. But then in the end, you have a summary, right? And it's chat result.summary, and you get the summary, right? So, pretty straightforward. Sequential chats. So this is when you want to have, one agent talking to many other agents as a sequence of steps. So this pattern is useful for complex tasks that can be broken down into independent subtasks. So you have this carryover here, right? So everything that happens here, you summarize it and you carry it over, right? So it can be, again, just that summarization that we saw using LLMs. It could be the last message. There are different ways to define it. But yeah, basically, agent A talks to B maybe a few times, then the summary goes here, and the agent says, oh, I worked with B, this is what we figured out, help me to solve now this next step. Then they talk and so on, right? And the carryover is sort of, it stacks on top of each other, right? So when you're here, you get the carryover of all the other conversations that happened before. So how does this work? So assume we want to do, again, simple arithmetic operations using agents. So I'm just defining a whole bunch of agents, and adder adds a number, and multiplier multiplies by 2. It multiplies by 2. So these are just very simple agents, right? But the way, so you would define them as we saw before. But in terms of chat, for this type of chat, for the sequential chats, this is kind of how it works. So number agent is the one initiating the conversation, and then it asks the adder agent to add 1 to 14 2 times, and then it asks the multiplier, then the subtractor. So it's a very simple example again, but it's just to give you this idea that you have an input, some agent is gonna do something on that input, then that's gonna be then handed over to the next agent, and potentially you're gonna end up solving like a very hard problem, right? So in this case, and you also get summaries, right? So you can see the summaries of the first and the second and the third and the fourth chat. So you see that the summary for the first one is 16, because we started with 14, and we asked the other agent, and the other just adds 1, and it's going to do it twice, so 14 plus 1 plus 1, 16, and so on, right? So in the end, you have 15.5. Yep?
So I'm kind of confused. So the summary is built in? It's like very specifically built into the Autogen?
Yes. So this summary, in this case, I didn't say it explicitly. In this case, I'm using like the last message, but it could be what I showed before, like an LLM summarizing the conversation. Because in this case, we're just working with numbers, right? So this agent, the number agent, it only says a number, so 14, and then it's going to get 15, 16, and then when it starts the conversation here, it says 16, right? Because that was the last message, right? So this is the carryover, basically. And in this case, it's the last message, but it could be a summary of the conversation. Or it could be your own defined function. You could do anything you want. Maybe it's a bit more confusing here because it didn't show how these agents were defined. But do you get the intuition of or what's going on? Or
so that's what the next agent sees in the call is whatever the result of the summary method is?
Yes, exactly. So there are actually two things. So there is what agent A is going to say. In this case, agent A only says 16, like the number that it sees. But it also carries over the context, right? So you can have a message from A, and you can also have this summary as like the context for that prompt, basically. So you can have A sending a message and use basically this carryover as the context for that message that A is sending to C and A is sending to D. In this case, again, it's very simple. Basically, you're just taking the last message and sending it forward, right? Cool. And you see the carryover here. So it's 16 and then 64, and here 14, 62, then 4, 16. But anyways, cool. Group chats. So this is when things start to get, you can start doing more sophisticated conversations and interactions, I would say. So all agents here, they contribute to one conversation thread. So the scenario here is, imagine you're in some meeting room, there's someone moderating the conversation, and there are people that want to talk about something, right? So someone starts the conversation, and then this chat manager is going to decide who's going to talk next, and then it broadcasts the message to everybody. So that's kind of how it works, right? So basically, agent B says something, then it broadcasts what it said to everybody, and then it chooses the next one, right? So how does it choose the next one, the group manager, right? It can just do round robin, so first A, B, C, D. It can do random, it can do manual, so the human can say what it wants, and auto, the LLM decides who to call next, right? And yeah, you can even have like a Python function. You can have a lot of control here, right? So how does this work with auto, right? So auto is when the LLM decides who is going to talk next. So basically the way it works is you create descriptions for your agents, right? So you say I have an adder agent, so you define it as a conversible agent, and then you add a description, say what it does basically, right? And so adds 1 to each input number. This multiplier multiplies each input by 2. So you basically describe your agents, right? So that's what the LLM is going to use to decide who's going to talk next, based on the query, on the original message, on the description of everybody, of every agent. It's going to decide who's going to talk next. If you don't provide this, then it's going to use the system prompt of these agents, which might be or not be a good idea depending on your use case, right? So yeah, okay, so first thing, you define your agents, give them a description, right? Just so the group chat manager can decide who's gonna talk next. Then you instantiate a group chat. This defines the basic parameters of this chat, of what's gonna happen, right? So a group chat here is saying, oh, these are my agents. These are the agents that are gonna be sort of talking to each other, right? Messages here is the starting history or context for this conversation. So just like in meetings, right? Sometimes you have you have a context in mind, right? So in this meeting, we're going to be talking about A, B, C. So you can have some prior context here before this whole thing starts, right? Yeah, to help establish predefined interactions, set up information or anything you want. Yeah, we're using auto here. So we're using those descriptions to decide who's going to talk next. And max round, it means 6 times. So we're going to select an agent to speak, and the agent is going to speak 6 times, okay? So yeah, so basically, again, you define your agents, give them a description. Group chat, you say who's going to be talking. In this case, all of these agents, right? No prior, in this case, I'm not giving any context, any messages here, and I'm just going to say, hey, it's going to be 6 turns. And then you finally have the chat manager, right? The guy who's going to coordinate all of this. It takes a group chat as input, which is this thing here. And we're using the auto mode, and it's going to use the descriptions of the agents, right? So there's nothing fancy going on here. It's just one type of agent, just like you have conversable agent. You also have group chat manager, right? And then you can finally initiate the chat. So in this case, we're using the number agent to initiate the chat, and then this number agent says, my number is 3. I want to turn it into 13, right? So imagine, again, I come with a number. I am attending this meeting. I come with a number, like my number is 3. I want it to be 13, and you guys provide arithmetic operations, figure out how to do this, right? And so this is kind of what happens, right? So my number is 3. I want to turn it into 13. So in this case, the chat manager, so it says this to the chat manager. What the chat manager does not appear here in the logs by default, but it's doing these choices, right? So again, my number is 3. I want it to be 13. So it says, hey, multiplier guy. So the multiplier says, OK, 6. I'm going to multiply by 2. And then, hey, adder, the adder, oh, I'm going to add 1, 7. Multiplier again, 14, 13, and there you go. This ends here, right? So I guess, so hopefully you can kind of see now how it's a simple example, but how this could be expanded to more complex scenarios, right? So you start with the problem, and you have a bunch of agents that are capable of doing something specific. You start with a big problem. You let them figure out how to solve the problem, right? Okay, now there are other interesting things you can do, right? I'm not going to go super into the details, but you can have introductions, which is like what humans do too, right? So maybe you go to a meeting, you don't know anybody, so you say, oh, I'm Gustavo, I work for Huawei. You know, so you can have the agents sort of introduce themselves to the other agents, because right now, if we don't do anything, only the group manager knows the different people, right? The agents don't know each other. But if you can have these introductions, right? So if send introductions is set to true here in the group chat, the agents will introduce themselves to the other agents in the same chat. This is going to be the agents. They're going to say their name and their descriptions. So I'm Gustavo. I do blockchain, right? Something like that. And it's really how it goes. It's as simple as that, right? What else can you do? You can constrain the speaker selection. And this is very simple too. So maybe you want to say a number agent, you can only talk to adder and yourself. Adder, you can only talk to the multiplier and the number agent. So you can restrict which conversations you want to have, right? You were allowing, either allowing or disallowing, right? So basically you have these transitions, and you can either set them as allowed or disallowed, and that's it, right? This is just the same type of example with these restrictions in place. Right, then this can get very complicated, as complicated as you wish, right? So you could have, again, this group chat happening as part of a sequential chat that we saw before. So here you would have this group chat manager with the introductions happening. And so you have 3, you want it to be 13, and once you get 13, you want it to turn it to 32, right? So you could repeat that same thing over and over, or have very complex interactions going on, right? So here's just kind of showing the same thing. So 3 eventually becomes 13, and then the new chat kicks in, right? Now it needs to be 32, and then it's going to do lots of other operations until eventually you get to 32. Right. Nested chats. So this is, again, the idea of encapsulating. So maybe you have a lot of different conversations going on, but you want to have some very simple interface, right? So if your message passes the human in the loop and triggers this nested chat, so you can define the conditions for this to be triggered. But let's just assume that it always triggers if the human doesn't interfere, right? So then a lot of computation is going to happen here. And then you're going to get a summary as a result. By default, the nested chat handler uses the summary, but you can use the last message as well. And yeah, this is basically just a way of encapsulating things. So let me try to show something perhaps a little bit more closer to what we would do in practice. So conversable agent, again, human proxy, so it doesn't talk to LLMs. It doesn't require human input in this case, because we're going to define the messages here. And then you have this code writer agent. So you were a code writer, generate Python code in Markdown format, do not show the output or blah, blah. So it does it basically, do not run it, like just generate the code, right? And then you have the executor. You're a code executor that runs Python code locally. So here it's using like Docker, for instance, right? Could be anything. So yeah, so you define your agents, step one. Here are my agents. So I have a human, proxy, a code writer, and executor. Then I define the nested chats just to make my life easier. So some message is going to come here, and then the writer, so the message is going to be sent to the writer. The writer is going to write code. Then here in the nested chat, I'm saying, hey, writer, now send it to the executor. The executor is going to execute it. And the summary method is going to be the last message. So then it goes back to the user, right? So this is the nested chat. Here's how you register the next chat. And then you have your initial query here, right? So write code to turn the number 3 into 7 by adding 4. This is very stupid, but anyway, this is a very simple request, right? But then in practice, what happens is, again, you have the human proxy saying that sentence here, right? That we hard-coded here, but this could be as complex as you wish. So and it goes to the writer writes, and then it starts a new conversation, and then it sends to the executor executes and sends the result back, right? So again, you're basically, you as a human say, hey, I have this problem. Then some agent who's very good at coding is going to figure out the solution. It's going to say, okay, this is the solution. Now it needs to run. Hey, executor, run it for me. The executor runs it, and the human gets the result back, right? So again, simple example, but kind of shows how you would get started. Now, so this is basically the main stuff I wanted to cover regarding Autogen. There are a few other things I want to talk about if I have time. Yeah, maybe I have a few minutes. Okay. So memory, right? Memory is this big thing. Kehelia talked about it. There are different interpretations and different types of memory. But let's just look at something very pragmatic, right? So Mem0, so Autogen doesn't provide any memory support out of the box, unfortunately. Or fortunately, because then the frameworks is smaller. But yeah, so basically memory, you sort of have to use something, right? So Mem0 is like a famous framework to deal with agent memory. So it has this hybrid database approach. So internally, it has a vector database and a key value database. But the way it works basically is for every, in Autogen, you have the sessions, right, where you have agents talking to each other. You have the agents like IDs as well. And you can maybe even have like a user ID. So the key point here is you can associate or you can add memories to this Mem0 thing and say this is a memory that happened in this session with this agent and so on. So this data is going to be inserted in this cross-database thing, right, in a smart way. And then you can search it later on, basically. So the whole idea is that over time, and this has to do with the data flywheel too. So over time, your agents are going to be learning things. They're going to be learning human preferences and all of that, right? So the idea is you store this in a database with this proper agent IDs in the sessions, and then you can do fancy searches, right? So it searches automatically across these different data stores, and then this goes to some scoring layer, and then you get the result back, right? So yeah, so if you have a conversation kind of like this, you just do like memory client add in your conversations, then you can have user IDs or agent IDs. So this is how you just add stuff to memory. Then here is a slightly more sophisticated example where what was the issue with my TV, get context-aware response. So this is to show basically how you would retrieve memory, right? So you have this question here, then you would search the memory, and then you would add it as context in your prompt. Then you would prompt your agent with that context from the memory. So this is very low level compared to what Kehelia was saying. So you still have to manage a lot of the memory data yourself, but the search capability that happens in the backend is quite neat. And yeah, and then this could be part of a multi-agent conversation as well. So okay, so if you want to just try things out in your laptop, perhaps, just to get started, right? What do you do? So I love Ollama, right? Ollama is this thing that allows you to run foundation models on your laptop, okay? It does clever stuff. So if you have a dedicated GPU, it's going to try to use it. If it runs out of, if your GPU has low gigs of VRAM, then it's going to run on the CPU. So it figures out all of this stuff by itself. If you don't have a dedicated GPU, it still works on the CPU. It's going to be slower, but it still works. And how do you do, right? So you go to Ollama, you search for a model. Okay, you first go to Ollama, then you have to install Ollama. Okay. So if you're on Linux, then just a curl, you run this, you're good. If you're on WSL, it still works beautifully. You just go there, curl, blah, 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 you have this installed. So very easy. One command, you're done. Then you literally just search for the model you want to play with, right? So let's say I want to play with Llama 3.2, which is very recent, right? It's like this small Llama version. So here there are different tags. So maybe you want to use the 3B version. So to get this 3B version, you would just run Ollama run or Ollama pull to get the model first. If you just do run, it's going to pull and run it, and that's it. But there's a little thing here that is actually very important. So if you go here to 3B, right, you see that there are many tags. So if you look carefully, you see that if you just do Ollama run Llama 3.2. It's going to get the latest version. The latest version, in this case, they consider it to be the 3B version. And this version, because it has hashes, you'll see that it actually maps to this quantized version here. So just be careful, right? Because basically, if you just say this, you might be thinking, oh, I am using the full 3B version. But in reality, it will always default to a quantized version, typically a Q4. So just be aware of what version exactly you're using, right? Just not to be misled, okay? How do you integrate this with Autogen? And it's beautifully simple. So you just go to the config where we had the OpenAI keys and stuff. You just do the name of your model, which is this name here in this case, or 3B. It depends on how you pulled it, right? But you give it the name, and this is where the Ollama server runs on this URL here, and you say Ollama, and you're good to go, right? So very easily you can run stuff on your laptop, local, no data going to servers anywhere, and you can test this out. You can play with it, kind of get a feel of the API, get familiar with the API, and this is kind of cool. That's sweet. I love Ollama. And it's very popular too. In Reddit, there's the local Llama discussion group. A lot of nice stuff happens there. It's really, really nice, especially for experimentation. There's Autogen Studio, which is a studio that implements all of this Autogen concepts, so you can, it's more of a low-code platform, so you can use that to experiment as well. Other agentic platforms. So I'm running out of time, so I'm just going to be quick here. CrewAI, so there are these different platforms, right? I talked about Autogen, but there are other offerings, of course, right? CrewAI, so the philosophy or the abstractions are a bit different. It focuses on processes and tasks and the agents. And it's very declarative, so that's their take on it, right? So you define the agents in these YAML files with role, typically a role, a goal, and a backstory, which is like the context, really. So you define your agents in a declarative fashion. You define your tasks in a declarative fashion and link them to to the agents, right? And then you have different ways of executing this process. It can be sequential, hierarchical, but this is, again, just to give you some insights, right? So it's more of a declarative way of defining agents and tasks in the process. Then there is OpenAI Swarm. So there's a lot of hype around it, but I guess everything OpenAI becomes big, right? But if you go to the GitHub repo, like they say, experimental, educational, right? So take it easy. We're just starting, right? We're figuring things out. So I personally haven't played with this one, to be honest. So I know little about it, but yeah, it's still in a very experimental stage, right? Just so you know. And then another big player there is LangGraph, right? The guys from Langsmith. And the abstraction level here, as the name implies, is a graph. So basically, if your use case can be easily translated or naturally translated to a graph, if you think of your agents talking as a process, like almost like a graph, right? I have A, and A talks to B, and there's this loop, and then if you see it as a graph, this is probably the best tool you want to use, right? Because again, Autogen is about conversation patterns, really. So you're sort of limited to those patterns in a way, although they're flexible. If you really tweak it, you can do whatever you wish. But if your problem maps well to a graph, just use this, right? I guess it boils down to using the right tools for the job. Of course, you have to consider your team and how familiar they are with these tools, but there are different tools. And yeah, this is just a screenshot of their webpage, and they have some nice apps you can use to help build these graphs. You can do it with drag and drop. You can use LLMs, and they'll start putting nodes there. So it's kind of fancy. And again, if you see your problem as graphs, you should probably be using this. This is just a comparison. I'll not go into the details, but just in terms of stars, right? So Autogen is super popular. It's probably the most popular one, right? 32K stars, which is quite a lot. And you see that OpenAI Swarm is more popular, or has more stars than LangGraph, even though it's still experimental. So anyways, but this is just a summary. You can check later in the slides. So I just want to finish this talk by saying a few words about standardization, right? So now it's a little bit better, I guess, but still people are building their agents using different tools, different frameworks, and then it's really hard to compare agents to one another. It's hard to reuse agents. Maybe you have an agent in Autogen, I have an agent in LangGraph, right? It's hard to develop, and this, I think, is a key problem, right? So if you want to build some sort of infrastructure tool or some tool that would be applicable for any agent, this is really hard because these different frameworks have different assumptions. So basically, there's no single interface, right? There's no easy interoperability between different types of agents, right? Sorry. And due to the increased adoption of agentic cognitive architectures, this is going to become a problem for sure, right? And this is just not me saying that. So IEEE is working on a standard for model agent interface, for large language model agent interface. So a unified interface basically for agents, right? To enable interoperability. There are also these folks from AI Engineer Foundation that have their own take on it. So basically, IEEE is sort of still working on it. They don't have like a concrete proposal so far. These guys are trying to. So it's a unified, the idea is to have a unified protocol that is, because it has to be very flexible, so then it has to be easily adoptable, if that's a word, by everybody. So it needs to be really simple, right? So in their mental model, an agent basically, or the protocol involves these three things: tasks, steps, and artifacts. So a task denotes one specific goal for the agent, which can be very specific or very broad. You have a step, so a single action that the agent should perform. Each step is triggered by calling the step endpoint of the agent. And an artifact, which is basically the output of the work that the agent has done. So in their mind, basically, there are other API endpoints, but roughly they say you need these two. So you need to be able to create a new task for some agent, and you need to be able to trigger the next step of this task. So you ask the agent to do something, then maybe you can have the list of all the steps if those are predefined. If not, you can just call this steps, and then the agent is gonna execute its next step, which could be talking to another agent, calling some tool. So yeah, they're trying to figure out some common interface here, and AutoGPT uses this and is trying to push this. So there are some big players behind this. Yeah, I think it's basically still an open problem. People are trying to figure out the best way to go about it, to be honest. Okay. Cool. So I talked a lot about Autogen, showed a lot of code. What now? So what happens beyond this presentation? So I think there are a few things. So imagine now you have this system that has many agents that are talking to each other, doing a whole lot of stuff. It's really hard to turn this into a real product. So Gopi is going to be talking about it. Not about productionizing AIware, right? And maybe your AIware has agents, right? So yeah, so it's really hard to, Felipe and other folks were talking about how it's hard, even Ahmed, right? Like how it's hard to select your model and how it's hard to select the parameters of your model. And here it's just even worse, right? Like taking care of all these agents. And one of the key problems is observability. And Ben is going to be talking about observability, right? So you have all these agents working perhaps autonomously, and maybe a few days later you want to know what happened, right? You don't want to read like a billion log lines. And what is the appropriate abstraction level? How do you even know what the rationale of the agents was for like taking an action, right? Why did that agent do that thing, right? What drove it to do that thing? So this observability, and especially not just telemetry, right? Not just the messages, but the reason why the agent did what it did, this is really hard. And this is what Ben and other folks are trying to solve, right? So he's going to be talking about it. Now, there are other tools, right? For memory, for instance, there's something called Zap. So there are other alternatives in the market for sure. And I think this is going to evolve quite a bit. The frameworks are relatively, you have to do a lot of work to get, if you really want to have good memory and stuff. So I think this is going to improve over time. What I showed to you was Autogen version 0.2, which is the stable version. For some reason, they skipped 0.3. They don't like 0.3, but now they're working on 0.4. And they're trying to make the API a bit nicer. As I said, there are certain things that are misleading. After working on this, if I have time, I may submit a few PRs to their website to correct some of the stuff in the documentation. So they're making progress. They're the most popular ones. It's cool. They're coming up with a new version. Backwards compatibility is reasonable, so it's not that big of a shift. Now, there's a lot of cool stuff on YouTube and Coursera involving agents. So if you want to get started or get an idea of how those other frameworks work, you can go there. There's some, even in Coursera, some very nice stuff going on there. We're going to have some hands-on happening here in the next few days, so make sure you check out FM Arts. I was going to talk about autonomous software engineers, but Kehele covered agents in software engineering, so I'm not going to say much about it. I'll just conclude by saying, as I had like in that slide in the beginning when I talk about cognitive architecture, that really is the problem, the open problem. So autonomous software engineers, so there are folks like Agentless that are saying, why do you even need agents? You can solve these sweet bench problems without agents or just one agent, right? You don't need to go crazy, right? Then there are other folks like from AID where they say, no, this is a very complex problem. You got to decompose it, and you're going to have like a bug fixer agent, a test agent. And so there's no consensus, right? It's an open problem. People are trying different things, and there are these extremes. People using no agents, and the paper is literally called Agentless, and people using agents everywhere. And there are pros and cons, right? So typically, agents will help you when you have complex problems, but remember, all these conversations, if they involve LLMs, you're paying for them. There's latency. There's a lot of complexity too, right? When you bring agents to the table, right? And that's it. Yeah. Thank you. Thank you.
For the great talk. Do we have any questions? thank you for the talk. Regarding one of the examples that you showed, the calculator, the
Okay.
the question is, so when one agent responds with an answer, how does the other agent like verify whether that is correct or not?
So correct is almost like domain specific, right? So in this case, we're not. I didn't focus on that. I just let the conversation go. I think what you're hinting at is what if something just goes wrong in the middle, and what happens from there, right? So that's why you gotta have these other mechanisms to shut down conversations, or even have traditional tools underneath. So it is an open problem, really. Like I don't think there's an easy answer to this question. Even so I think it has to do with observability too. It depends on like if your system is running live and you're interacting with the agents live, or if they're doing their thing and you're gonna check the next day. So there are different models and types of applications too. But it's hard. I think that's basically an open problem, right? How do you verify that the agent is doing the correct thing? It's almost like saying, like, when I prompt, how can I guarantee that the LLM will give me the correct answer, right? It's hard. Sorry, that's maybe not a good answer, but it's a very hard problem, for sure.
Gustavo?
Yep.
All right, thanks for the great talk. I learned a lot. There's a lot of framework I didn't even aware.
Yep.
So if I'm a developer, let's say, my company asked me to choose one of the engine for the software development task. So which one should I start? Or I try everyone? Or do you have any recommendation for different level of developers?
Okay, in terms of these multi-agent frameworks, different options, right? So I tend to think that you really need to think about your problem first, because the key difference, or one fundamental difference between these frameworks is their abstraction, or their mental model, right? So if you see your problems as conversations, Autogen is great. If you see them as graphs, so graphs typically is where you kind of need more control, right? Maybe you want to be more careful with how you specify the transitions and stuff. Then probably LangGraph is a good option. So yeah, one, think about the problem you have. Second is you probably want to use some tool that has, or some framework that has a good community around it, because maybe it's the best tool ever, but if you're the only guy working with it, then you don't have community help, and the thing will probably not evolve very well. So the community health, the health of the ecosystem, I think, is very important too. So yeah, think about your problem. Try to stick to the big players, I would say, at least for now. This is all very new too, right? It's evolving like crazy. So yeah, I think those are my key points.
Yeah, sorry, follow up a question. So how do you see the engine gonna change the software development working flow? So eventually you need to integrate engine into the software development flow, right? So how do you think the current software development flow going to be changed?
Oh, okay. This is a very big question. So it depends on, like, I think if we focus on SC 2.0, which is the current paradigm, let's say, what we have right now is this amazing things like Copilot and even like Cursor, Continue Dev, that are all these great tools to help you write code, especially the code that is mundane and repetitive, and glue code, stuff like that. It's very great. You can see diffs, you can see different options. They're really trying to nail the interaction design, because you really need to have something efficient. If you just show 15 different alternatives for a code completion, nobody's going to use it, right? So right now we're seeing this, right? Going from there to agents, I don't know when it's going to happen. How do I think this should work in practice in the future, or whatever? So I've been working and thinking about all this stuff with Ahmed, right, in the SC 3.0 and stuff. And in our view, I would say I would like to have an ID. And so first, I would like to have an agent that is just one interface. So I only talk to one thing. I don't want to talk maybe to 10 different things. Inside of this one thing, maybe you can have 15 different agents. But I want to have one agent, and I want to have that agent to help me figure out what my requirements are. And I think this needs to be multi-channel. Sometimes I want to talk. Oh, I want to have this. Sometimes I want to, I I just want your help to get me started, but this algorithm, I want to write it because it's just faster for me to write this code than describe what I want to have. Maybe I want to draw. Maybe I want to draw my UI and you make it into like a little prototype, right? So I think you need, ideally, one agent where you have all these different channels to get you started. And then, yeah, in the SC 3.0, we have this idea of once you nail the requirements, it becomes a search-driven exercise to figure out the best cognitive architecture, so the best agents, the best prompts and everything becomes a search problem. Very hard problem to solve, but my dream would be that. Like, I don't want to fight my ID. A lot of times I'm there and I'm like, man, like I just want to move this button there. I don't know this React API here, and then I spend like 10 minutes. You know, if I could just drag and drop, or if I could just tell it and it does what I want, right? So ultimately I want an ID that helps me get there, right? These are my very personal thoughts on this.
So you're almost answered my question, but not quite. So
okay, fair enough.
So my question was, what are quintessential types of things that you want? Do I have some? So? Yes. Yeah, okay. That you want agents to do, because one option is, right, that seemed like an example that you had, is you basically break down into a switch statement or if statement, and then basically you send calculator stuff to calculator agents, calendar stuff to calendar agents and whatnot. Yeah. But agent concept is not necessarily here. You can select the workflow for that as well, right? When you gave these examples that you talked about software engineering tasks, you also talked a single agent. So I'm just trying to understand if this agent stuff is kind of a distraction from, you know, some other ways to solve the problem, or are there really tasks where you do need to have, you know, the agent is actually is a good abstraction for actually getting stuff done? Right.
Very good question. So remember that even here in Autogen, you can have these nested chats where you can hide a very complex interaction among many agents into like one thing, right? So maybe for the person as an outsider, you only see like one agent, but underneath a whole crazy interaction.
Yeah, but I mean, what's the point of having these agents if you can basically, you know, break down into some workflow, which, you know, scientific workflows have special engines to do. Like, so if you can specify in advance, like, what's the point of having these agents, right? So that's really what, I mean, I'm trying to see what other applications where really, really you need multiple agents actually doing stuff.
Okay. I think there are a few important points. So one is you typically want to have agents, or the main use case is when you have a complex problem and you want to decompose. And you want to have different agents that are specialists in specific tasks, right? So maybe you have some agent that is a very good tester, one that is a very good
that's
debugger.
A switch statement, right?
That's a switch statement. But what I was going to get to is you don't need, with Autogen, for instance, you don't need to prescribe all the interactions beforehand. So just like you had the chat manager thing happening there, so you could delegate, and that's where the flexibility, I guess, comes from. You could have something like, I have a good tester, I have a good debugger, I have a good whatever, I have static tools A, B, C, D, figure out how to solve this problem.
Makes sense. Or you can even have teams and then do voting or something and see performance and then,
exactly.
You know,
so you don't need necessarily to predefine all the interactions, right? It can, a lot of the magic actually comes from this dynamic interactions, and then that's why you need observability to figure out what's happening.
So first a comment was Audra's question. So generally the reason why we want to have agent is we want to have that level of abstraction, saying, as Gustavo said, we need to have one developer and another person doing the tester. And the analogy here, I think I made the same comment yesterday, is they prefer to have this set of separation because technically you want to evolve and improve the developer, and you want to evolve and improve the tester as the things they interact and goes on. But if underlying you have the same one, and the way AI people does is doing it with a...
Just to be clear, I don't mean that, I understand that, but what you can do is as long as you can anticipate these interactions in advance, you can program them in and say, I have 25 different LLMs, each one represents a different persona, and I'm going to write a workflow where somebody writes code, then somebody reviews code, then somebody writes tests, then somebody executes tests. and that's all prescribed in a regular workflow. It's a standard process, right? And you don't need any agents. It's just like, so you need agents when it's asynchronous, and sometimes you want to communicate, sometimes you don't, or maybe you need to save time. And I don't quite see a lot of tasks like that where it's unclear in advance what's going to happen. So that's really what my question was about, right?
But in the way we see this is there's already different camps with different terms. So I'm in the camp. So remember, Berkeley has a term called compound AI systems, and there's a bunch of AI folks that pick from the old term called agent, which is a very vaguely abstract notion of the things. Many people, including myself, think they're actually the same thing. But if you're really thinking about the compound AI system, which is in essence what you're saying, but sometimes people think agent is somehow like a human type of things which does some of the task, then that's a very different thing. But the way, at least I hope maybe many people here, is essentially just a component in that whole compound AI system.
Yeah. One thing I would like to add, maybe I'm talking too much, but that just crossed my mind and that I discussed with some other folks before. I think even in the current paradigm where you're using, continue.dev or copilots and stuff, I think there's a missed opportunity there, which basically we're using this AIs, right, to help us write code faster and stuff. But if you have an agent, right, or even the GitHub Copilot or similar could be doing this, but if they watch you work every day, right, and they are seeing the type of stuff that you know and that you don't know, right? So maybe you always make this mistake here and there, or maybe these are the functions that you're always asking about, right? So ideally, over time, this agent should know you, right, and your preferences and your weaknesses, and so I think there's a lot of opportunity for making better developers by going literally like, oh, last week this is all that we have done. This is where you seem to struggle. These are some pointers, right? Or maybe this is what I think you should be looking into and improving, right? So if we had this full circle thing going on, I think, because we're always discussing about how, rethinking the curriculum in computer science, or what we can do to make developers better developers. So I think there's a big opportunity there for the agents to help you as almost like a mentor, right? Where they see where you're struggling with and give you hints and pointers.
Yeah, I want to have a comment. Sorry.
Okay.
So actually a question to Gustavo, and maybe for all the audience over here is like a agent-oriented software engineering is nothing new, right? It started in early 2000.
True.
With that paradigm, and there are even textbooks and tools available over there, and people by that time feels it has limited adoption. Because that again different type of framework available, and they use different APIs with these agents and so on. And now we come back to this time. Now we have this so-called FM-powered agent. But at least the way I talk to many people in the area, thinking this time is different actually. Even though you can develop agents, use these different framework and so on, but the way they interact with each other is still through these kind of natural language. It doesn't have to be English, of course, it can be other language, but the way they do that would be actually natural language, and that's why the reuse and integration of these different agents, if you want to form, whatever use case of these kind of multi-agent based system, is actually much easier, right? So I think that's probably something we community as a whole needs to think about. Under this type of paradigm, what is usually or what should be the real programming model available over there, and in terms of exchanging these kind of natural language based kind of conversation or with an API and so on. How do we do that concise, effective, and so on, right? But at least we remove the barrier of incompatible API and so on among these agents.
So natural language is cool because the barrier is low in the sense that you can easily get something out of it by just speaking in English. But the language can be very verbose. There are a billion problems, right? It can be ambiguous. As I said, I really believe that in the future we'll have IDEs that are not just, don't get me wrong, like, I think LLMs are cool, FMs are cool, but you won't be using FMs for everything, right? Like, I think we still need our tools. Writing plain English or talking plain English sometimes is not the most effective way of doing something. Again, maybe I just want this button that is here to be there. I would rather just draw on the screen in 2 seconds and get it done instead of move the button with the text blah 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 to the pixel blah 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 and the LLM going nuts, and so anyway, so I think language is extremely important. It opens many doors, but I think it's going to be a combination. If we want to have a very effective ID, you got to find the fastest way to get your job done, and I think this involves different channels that are not just natural language. But this is a very opinionated, just my thoughts on this.
Yeah.
Yep.
Okay. Thank you. Thank you so much for the great talk.
Thank
so
you.
there is a problem always puzzles me. So the output of an agent is not always necessarily deterministic.
Yes.
When you have so many agents working in a big system, would it have like cascading effects that will like eventually give, I don't know, contradicting results? So I give it a same input, like it will give me different answers over time.
Right.
So is that a problem? Is that a concern?
It is a big problem, a big concern, and a big challenge. Even with prompting, right? Sometimes you just go to ChatGPT and I don't know, maybe you want it to summarize something, right? And then it does it, and then you're like, actually do it in this style, or add a little bit more. So it doesn't do what you wanted, or maybe it just hallucinates and does completely. So now that you have, like, I don't know, like you could have hundreds of calls to foundation models, right? Things can go off rails very quickly, right? So it depends on what you want to do, how complex is the thing you want to do, how much room you have for errors. There are things that are critical. Probably this might, at least given the current state of things, using this type of framework for very critical things is probably not a good idea, right? But where in the use cases where you can afford some errors and maybe retrials, and maybe it's good enough, right? But it's a big problem, and a lot of it has to do with how much human intervention do we want to have. Because you could have checkpoints. You could say, hey, you go up until here, and from here on, you need my human approval to move forward, right? So, but then how much human intervention, right? And I think it's an open problem, a big problem, not easy to solve, and I think it's use case dependent.
Cool.
Thank you.
Just we have last question over here.
Yep.
Where do we go from here? I love how you end up with that. So you have given us, you and Kehalia, such a strong foundation.
Oh, thank you.
I'm just wondering how many of the students here are excited to build an agent for software engineering tasks? Like
Please raise
just
your
raise your hands. Yeah.
Otherwise, I'm just
Yeah,
gonna
okay,
cry.
so look at the number
Yeah,
of hands that
yeah.
went up, right? So where do we so in software engineering, imagine that we have, there's like this Rose Festival that people had with reusable artifacts.
Yep.
What if you have like an agents festival, right? When you
Right.
go to a conference or something, all these people who are building software engineering agents that we are meeting, we are talking, we are sharing, we are letting our agents maybe interact while we have a
Absolutely,
meeting,
yeah.
our agents interact with each
Yeah,
other,
yeah.
and we can share practices and share what we are learning and share what we are
Yeah.
experimenting. So we will go a lot faster, we'll make a lot more progress, we'll go a lot further if we all share like what we are learning, what's working well, what's not working well. So
I
that's
agree.
what I would hope, that this is the first event,
Yep.
and for the students who are here, who are really the future of our community, I hope that we are all excited to share with each other and learn, and so that we can make a lot faster progress together.
Absolutely, I agree 100%. Yeah, and just to wrap it up, like my take here was, this is a boot camp, so there was a lot of theory, like a lot of concepts, right? So Felipe went super deep into the prompt, and Kehalia with RAG and agents. So I just felt like that is awesome, right? But let's just also see kind of, if you were to do it right now in practice and use whatever tools are available, how you would go about it and how could you just get started, right? So that's kind of why there's so much code in my presentation and stuff, but it's just to have also this pragmatic view to complement what has been said before.
Right, very well said.
May has a question. Maybe the last
So
one?
have you thought of writing up a tutorial of sorts, just from the slides even, right? If you can, it'll be helpful to kind of share this with a lot more students.
I'm gonna, so I'm gonna be honest, okay? So when I was preparing this, so it was a lot of effort. Many slides and many screenshots, but I realized like I'm putting so much code, and this is 16:9, like it's terrible to show code to. So the proper way of doing this, honestly, or perhaps the best way would be to have some sort of session and tutorial where we kind of go through it and have people ask us questions and just have something live going on, right? So we have been discussing perhaps, hopefully we're going to have newer editions of this bootcamp. So having a tutorial on like a hands-on on agents would be pretty cool. Maybe we'll have something this bootcamp, like just some glimpses of how that could look like. But thanks. I think it's a great suggestion. I'm biased, but.
Awesome. All right, so let's all give Gustavo a hand again.
Thank you.